All right, so I'm going to go over this review page. So there's 3 different things that we are testing. 1, do you know how to use arrays, repeated addition? So decomposing factors is in the objective, but we haven't gone over it yet in class, so I'm going to cross this off. Okay, we are looking at word problems, and when you use repeated addition, groups of arrays, multiplication. Okay, then we're looking at, in a multiplication chart, we're looking at patterns. In a multiplication chart, we're looking at patterns. Okay, so here's the array. I have to make a repeated addition statement. I have to make a repeated addition statement. So I have 2 plus 2 plus 2 plus 2. 2 plus 2 plus 2 plus 2. Or I could have said 4 plus 4. Either answer is okay. That's kind of extra great if you have both. We're not going to talk about decomposing those factors. So they already have the commutative property. Remember, in multiplication, the factors can go in either order. You can switch the numbers around. 4 times 2 gets you the same product as 2 times 4. All right, so let's see. 1, 2, 3, 4, 5, 6. So 6 plus another 6 plus another 6. Or I could have done 3 plus 3 plus 3 plus 3 plus 3 plus 3. Okay, so commutative property means I have 6 groups of 3, which is the same as 3 groups of 6. It's not quite the same, but they equal each other. They have the same product. So group 3. This time, I have 4 3s. Okay, so I have 1, 2, 3, another 1, 2, 3, plus another 3, plus the last 3. Remember, an array is when you have things organized in kind of a rectangle. So over here in the commutative property, I have 4 groups of 3. 4 groups of 3 equals, has the same product as 3 groups of 4. So I can put them in different orders. Let's look at Leif. He wants to organize his M&Ms on his napkin using an array. The first one's shown. So what else can he do? Well, I know this is 3. 1, 2, 3, 4, 5, 6. Can he arrange them this way? So 2, 3, 4, 5, 6. So we've talked about arrays. Could sometimes go sideways, or you can kind of turn them around. Okay, what else do I know? How many do I have? 3, 6, 9, 12, 15, 18. So I have 18 of them. Well, I know 18 is an even number, so could I do it like this? 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's another example of array. 2 groups of 9. 2 groups of 9. So to explain my thinking, so the first array is 3 groups of 6. So the second, I made 6 groups of 3 because 3 times 6 is equivalent or equal to 6 times 3, which is 18. I can also make 2 groups of 9. 2, 4, 6, 8, 10, 12, 14, 16, 18. Or 9 plus 9. Okay, so I can make them go the other direction, or I could rearrange them. So I counted up how many there were. There was 18. And I could skip count by twos to get to 18. So I decided to set them in twos. Okay, so Logan read 5 books a week. He read 5 books a week for 4 weeks. How many books did Logan read? So I have to make an equation. I have to draw an array. So we have 5 books. 1, 2, 3, 4, 5. And he did that for 4 weeks. So here's 1 week. The next week, 1, 2, 3, 4, 5. Another week. 1, 2, 3, 4, 5. Another week. 1, 2, 3, 4, 5. Another week. So it's 4 weeks. 1, 2, 3, 4. And I did 5 each time. Okay. I also could have done it like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. So I did an array. So 5 books in 4 groups. So 4 times 5 equals 5, 10, 15, 20. Okay, 5, 10, 15, 20. I made, what did I do? I'm just going to write down what I did. That's what it means by explain your thinking. So I made a group of 5, then I made 3 more groups to get a total of 4 groups. Because I already had 1 group, then I made 3 more. I already had 1 group, then I made 3 more. All right, let's talk about Desiree. Desiree collected 10 tickets for 5 days. How many tickets did Desiree collect? Create an equation. She had 10 tickets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She did that for 5 days. Here's the first day. Here's the second day. 10, and then another 10. Okay, and then the last one, I made another 10. That was 5 days. 1, 2, 3, 4. Oh, I only did it 4 times, so I have to do 1 more. It's okay that I put it at the top. I didn't really have room down below. So how many did I do? 10, 20, 30, 40, 50. It was 10 tickets, and I did it for 5 times. That equals 50. It's an equation because I have an equal sign, right? My factors. Okay, Joshua, Amy, Sade, and Christian decided to put their tickets together. They had 16 total tickets. How many did they have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Each person earned the same amount. How many people? Each person. How many people do I have? 1, 2, 3, 4. So I have 4 people, but I don't know how much was inside of each group. These were the missing factor problems that we've been trying to figure out. So if I put them into groups of 4, each person. So everybody got 1 ticket. Then everybody got another ticket, right? I passed out 4 tickets to everybody. Then, I gave everybody a ticket. Then I gave everybody a ticket. Gave everybody a ticket. Then I gave everybody a ticket, right? These 4 tickets I handed out to Joshua, Amy, Zaid, Christian. These 4 tickets I handed out. I handed out. How many groups? 1, 2, 3, 4. So the missing factor was 4. Okay, so what are the missing numbers in these patterns? So let's look. 2, what am I skip counting by? 2, 4, 6, 8, 10, 12, 14, 16. Okay, what pattern am I looking for? This one. Oh, they're all 5, 10, 15, 20, 25, 30, 35, 40. So this one was by twos. This one was by twos, and this one was by fives. Okay, so on your test, we're going to have some hundreds boards and some multiplication. You're going to look for patterns. We've been talking about evens. We've been talking about skip counting by fives. We've been talking about that. So over here, though, I'm sorry. I have to go over and find the right answer. I'm missing 4, 6, 14, 16. 4, 6, 14, 16. Here's the one that I'm missing. That was 10, 20, 35, 40. 10, 20, 35, 40. Here we go. Okay? So we're going to practice some more tomorrow in class. If there's certain ones that you had questions, make sure you ask.